water security, and soils. You already saw something like that, the schematic from Miguel. This is related with the integration of the landscape, and our approach is the watershed. The watershed is a complex landscape to work with, since you can see a lot of users and a lot of interested parties in the watershed. You can go from the forestry producers, for agriculture, mining, the cities, and even what Miguel is working with, mostly the mangrove, the livelihood coming from the coastal zone. So this is more or less the approach of a landscape that we are really focused on in my unit. And of course, we coordinate with our colleagues, like Miguel, for example, is part of the sort of a joint project that usually we do. So as the whole category, we are focusing research in education at postgraduate level, capacity building, and technical assistance. And our goal is the sustainable management of natural resources in the watershed. This is an old, still standing strategy that CATE promotes, that is producing, conserving, and conserving producing. And if we are thinking about a watershed, we are going to use different scales in terms of time. There will be some activities that need to be promoted and managed at the short time, but we know and we understand that watershed management will need a long period. So we need also long-term horizons. In these schematics, what I wanted to show you is that our focus and our strategic and integrated transversal access is water security. We want to assure that our watersheds actually keep and sustain water security for the different interested parties. What we do is to work into these three concepts that you will see there. You see the concept of management. Management and watershed management itself came from a US term, English term, and management cannot be divided in the same word. For us, we divided management in Spanish is manejo e gestión, but it's the same in English. We divide that in one and two when I show this in English because the first part of the concept is focused in all the practices, activities that we put in place in the land actually to assure that we keep soil, water, vegetation, and biodiversity, the practices actually. The other part of the concept of management is based in what we need to do that. It has to do with the governance, participation, the different institutions, the financing part of, what we need to make this happen in the field. And the third one is a way of doing management that we call co-management. We have been promoting this in CATIE, let's say, the last 6 years, because the idea is that we need to articulate participation. We need to share common agendas between the different institutions and organizations working or having a mandate in the waters, in that landscape that we share. So the co-management actually came because, as you see, the waters is a complex environment to work with, and we are clear that just one institution or one organization itself, by working separately, will never achieve the management of this complex landscape. That's the idea of co-management, and that is something that we have been putting in practice with different projects in Central America. And then we have the watershed plan, which is our roadmap. We need to put, organize everything that we need to do, and we will see the components of the watershed plan in order to guide us in the management and to finally have water security and sustainability. And the implementing units that we have are, okay, you have a watershed management plan for a whole landscape, which could be big, medium, small size, but to definitely go into the land, go into the decision makers that are going to do or adopt or not what you propose, we need to go into a micro watershed management plan, like doing a zoom-in, or go into the farm level, like we need to do. The agricultural part, the farmer is the one that decides to apply or not what it is suggested in terms of conservation of soil and water, for example. And lately, we have been including as an implementing unit also the urban watershed. We are thinking about smart water cities because in the past, traditionally, CATIE has been working in rural areas, but nowadays it is more and more relevant to also include the urban part of the watershed and try to look into that part also and see what is happening there and probably adjust some of the approaches that we will need on there. What we do also can be summarized in this cycle called the integrated watershed management. This is trying to put all steps needed in order to intervene to work in a watershed. First, we need to go through a recognition, of course, of the watershed, the landscape we are going to work with, and identify the different stakeholders. The interested party that I mentioned in the first image. Then we need to go and work with the management organization, the manager committee. When we are going to intervene in a watershed, we cannot do it externally. We need a committee, we need people together with us following the process. This is something that we prepare or we work with in the early processes, in the early stages of this cycle. Then we, of course, need to do a deep characterization and diagnostic of our watershed, meaning that we need to understand how are the socioeconomical part and also, of course, the biophysical part of our watershed. From there, the diagnostic, which has a participatory part also, not just coming from research, coming from experiments, it has to do also with the integration of people, understanding what is happening in the watershed daily. So where we are going to actually get from the diagnostic the different problematics and also opportunities that the watershed might have. So that's the first step that we need to work with. The fourth is the land use zoning or planning, meaning that we have to see, according to the soil characteristic, the slope, the different elements of the altitude of the land, what we need to be there, to put specifically what needs to be in the landscape in terms of what the landscape is good for. And that is the zoning and planning part. Of course, we go through a baseline establishment, which is a set of indicators that trying to measure what we found in the diagnostic, for example. A typical indicator could be water quality. I mean, for the watershed, if we want to monitor what is happening after our intervention, then we can see like, okay, the water quality is improving, it's changing. This is an example, a typical example of indicator. Also, we can find that in this zoning, we can find that we have different land cover, we have different areas of forestry, for example, areas that we want to restore. Of course, always going to be the area of the different land cover that we have. And in the future, with our intervention program, we will need to move that indicator and increase some part of the restoration area or reforestation, or at least to avoid this to continue with degradation. And the next is the formulation of the watershed management plan itself, which is like organizing different projects specifically to give an answer to the problematic we found, or to give an answer to the opportunities we found in our watershed. Establishing what to do, the activities, the resources needed, and people that should be involved in the implementing part. Management for implementation, that is again organizing people that should be involved, the resources that need to be moved for implementation, and it is closely linked with the organization and implementation of the plan, which is actually, for example, this committee that started to work with us can evolve and be the leading organization that moves the implementing part of this plan. Of course, there is a process of follow-up, evaluation, and monitoring system that are actually responding to the baseline. We establish there already the indicators, and then we monitor what's happened in time after our intervention in the watershed. We also work on an interesting point that is systematization of experiences. What we do there is to actually document and write about the experience of planning and managing a watershed through a project, through any initiative that we have been working with. And the idea is, of course, getting the lesson learned, good or bad lessons, and communicate that in order for other people, other interested projects that wanted to do watershed management can learn from us, from our mistakes or our success. This is really important to build into the knowledge and share experience. At the end, what we want is to have institutionalization, like work towards governance and sustainability. The goal is here that many countries actually found this process of watershed management collected together within a law, for example. The watershed law, which is in place in Panama, is an example of a country that makes this as a routine, all this process that needs to be done. In Costa Rica, for example, when we have a water law that, as most of the countries say, that we need to work with a watershed as a unit of intervention. And at the end, the idea is to have this process like as a routine, as a mandate in order to sustain, in order to have this as a permanent way of working in terms of watershed management. And again, an instrument to operationalize the watershed management is the plan. The idea is to move from a current state of probably degraded areas, degraded watershed, or that need to be improved, to a perspective model where we want to move this situation to a better management, better practices, and of course people involved and collectively working for managing the water. So in that sense, the plan for us is that both a directive and a guideline for the process of changing and moving from a current state to a desired or perspective model. In our unit, we have 4 research lines. We are focused, for example, on resilience of waters to climate change, natural resource degradation, and human intervention. From there, we work, for example, in territorial planning, best practices of watershed management, emphasizing adaptation and mitigation, talking about synergies of those. Probably Miguel told you something about that. Hydrometeorological risk assessment. We also have here a course, a class, working with the disasters management. Agroecological zoning and assessment of critical zones for watershed intervention. This is what I mentioned about zoning, the landscape that we are going to work with. And of course, we have been working with incidents and designing watershed organisms or watershed committees with a co-management approach. A lot of experience in this project that I mentioned. I will show some pictures in terms of soil conservation there, but partly it is possible since we need to work together with the different organisms and organizations there. Then we have a part of our work that is focused on assessment of hydrological regimes at surface, groundwater, and coastal level. Of course, we have assessment of these different parts of the hydrological cycle, soil water dynamics, hydrological modeling, resilience assessment, and water footprint also. In terms of assessing the different parts of the water cycle, we have been using lately the isotopic methodology, the water stable isotopes, in order to trace and to see where the water is coming from, and this is why linked with these dynamics. For example, if we put the trees into the equation, all trees are using water, like improving it through infiltration or by using a lot through evapotranspiration. So this is part of methodologies and techniques, not new, but that we are incorporating. And of course, several modeling that we have been working with, and I will show you some of the results that we got from some of those models. And we have also the line regarding water security, multiple water use, and circular water management. Of course, trying to see this circularity of the water cycle. This is related also with the cities. We have been working a lot in biological corridors, which is also called urban biological corridors, with several standards to measure, to monitor the situation of these riparian forests and also green infrastructure in urban watersheds. Recently, we just finished a research here in Turrialba, where we measured as a green infrastructure actually the tree component of the city, and trying to measure from there the different ecosystem services that they are providing. So that way we are like, and we found that the green infrastructure, the spaces or where the ecosystem services are more produced are in the riparian forest, like through the Turrialba River, So this is part of what we do and try to get some research-based reporting, results strategies to reduce sediment load, and the soil water movement also in terms of, let's say the physical and biochemistry part of analysis. For example, this link with water harvesting that we have been working right now with the phases, for example. And this is just some elements of last focus on isotopic methods to, for example, to understand the effect of canopy cover into these processes in terms of evaporation into the soil in a tropical agroforestry field. And of course, we have this summary of our experience as a whole process of family working in tropical Americas, also recently published. And finally, I would say that we lately have been focusing our effort in one of the countries more complicated and needed in supporting society. We have been working with the regional development plan. This is in the southeast department in Massif de la Selle. And here we use this project in order to improve the way of doing zoning, the mapping of zoning of the different areas that need to be working correctly in the landscape and with neural network to generate more accurate processes here. And this is the core actually of watershed management plan. So this is more or less, and of course this is based in a, nowadays we need to put what we usually did in the past for watershed management or best watershed management practices in new approaches like ecosystems-based adaptation, like nature-based solution or building resilience, which are more or less things that we have been doing in the past, but like reorganizing it and refreshing it somehow, the idea of new approaches now. That you need to put this for project management, to demand for resources, for cooperation, etc. You need to use the term now. So that is not that different to what we have been doing in the past. So now let's go to the soil and water conservation. These are activities at the local level that maintain or enhance productive capacity of land, including soil, water, and vegetation areas that are prone to degradation. So the idea from these practices are prevent or reduce soil erosion and compaction and soil salinity. Also the idea is to conserve or to work towards water drainage and maintain or improve soil fertility. Of course, the activities should be selected and implemented, adapted or according to the local characteristics. There is a need for strategies at the local level in that sense. Interesting to notice that soil water conservation in the past has been understood as a side of watershed management, more or less the same. Watershed management is just soil water conservation. Nowadays, the concept of watershed management is far beyond that. We have to incorporate several additional activities like the decision-making process, people integrated in the process of decision-making. We put now the sociological term of analysis in that case. You hear the term resilience, the co-management part, specifically or mostly the co-management is part of the process, of course. To do soil and water conservation, you need people to be organized and involved, but for the watershed management, we have a holistic approach. You see in this figure that the soil and water conservation is the core of the watershed management, but we need to work towards decision-making, planning, natural resource management, and put together to have a watershed management complete. So it is more than soil and water conservation, but it is a core part of watershed management approach. So we need to talk also about erosion. You may have seen this. The erosion is a type of, actually the most destructive land degradation process, causing removal of soil, siltation of water reservoirs, and pollution of water sources. You see, we have these four types of soil erosion. The splash one that moves the soil particles. We have also the sheet erosion, real erosion, creating more footprints into the soil, and gully erosion that is actually, it says there that is not recoverable. You cannot recover from there. But at least the practices that are promoted to stop this to progress and to actually keep this under control. But of course, complete recovery is quite complicated from there. And if we want to summarize the type of measures that we can include into the soil and water conservation, of course, again, the purposes are runoff prevention, prevention of course of soil erosion and compaction, maintain or improve fertility in the soil, conserve rainwater, and harvest excess water. Harvesting water is really important, especially now in our areas that we work in the dry corridor in Central America. So water harvesting is part of the strategies of more current projects that we are doing. And harvesting water will have the effect of both help to infiltrate slowly aquifers, but also if you isolate the system, and you will see some examples, you can also provide with irrigation, you can also provide with additional income for the family. So the harvesting is actually a strategy quite relevant nowadays in some areas. And we can divide them in physical structure or measures, biological and agronomic. You see, for example, the dams, the forestation, the concords in agriculture are examples of what we can consider soil and water conservation measures. Also, we can summarize this in terms of biological engineering, which is, for example, how we move from a degraded landscape to an advanced stage when we have this biological part growing again, going to close to the characteristic that we expect in an original stage. And of course, the natural hazard control will go from less to more, and the process is ecological restoration there. So we start, for example, from just planting some vegetative barriers, introducing physical barriers to then in a pioneering stage we will see that roots are starting to recover infiltration, retrining the soil, and progressing in terms of organic matter in the soil, etc. And then you go through an advanced stage when you have trees already, when you have biodiversity coming back into our system, when you have biodiversity at the level soil, when you have structure of the soils recovering a better condition, etc. That is what is needed with looking for with the ecological restoration. And of course, from this paper of Gray et al. 2017, there are a lot of questions coming from practitioners to scientists. This is something that gives us the sort of motivation to continue researching, because people that have to be in the decision making of using or not using these measures, these bioengineering practices, want to know, for example, how to choose the correct species to put, want to know the structures to build, the work that needs to be done in that sense. Also, it is important to mention that there are experiences locally that you need to reconcile with what you come from Europe, like suggestions as a scientist. You need to also think about what they already know, what they already have done probably, adaptation of that, anticipating, of course, sometimes the structure should be degraded, the maintenance that has to be done there, and defining in general at the catchment, at landscape level, what to do with this measure. There are some examples there of the different bioengineering structures from this paper. For example, you will see here the second one, let's say, is grass buffer strips. Belgium, you have in the E, let's say, modified birch layers in Canada. So there are several palisades in France, several practices that has to do with bioengineering processes. And let's talk about what we have been doing here in Central America. Well, we have been working, as I mentioned, in water collection, water harvesting, and in this sense, what we do is to take advantage of the structure of the landscape itself and work towards manual construction, for example, of water reservoirs where we have natural depressions in the landscape. The idea is in this picture to see that there will be a recharging zone in our landscape, in our farm, in our micro waters, let's say. been working with has the main goal of contributing to household income, not necessarily to think about restoring the groundwater, but as a co-benefit, we have been seeing that, or we are looking to get this data actually right now with a thesis that we are finishing. So the idea again is that we have the collection, we have an infiltration zone, we build a land reservoir, and we connect this with irrigation for a population zone. Usually, I mean, the last projects that we have been working with this approach has been in Nicaragua, the dry tropic here, and they usually connect this irrigation part for horticultural activities, small areas in the household, so that way they continue on, of course, at a medium, bigger level of agricultural production too. The idea from there is that they continue generating income and avoid going to seek for additional jobs or additional activities outside the farm. That's the idea on there. And here we have some examples. This is for a project that we did in Nicaragua, as I mentioned, for 2005 and 2011 with a Swedish corporation actually. It was called for Cuencas too. And in this case, the processes there, the works were, in this case, for recovery of water infiltration or hydrological recharge. You know that in this case, you build these reservoirs but without any isolation into the soil. So slowly it can be contributing to the infiltration and recharge. Afterwards, we are now measuring this through isotopic, water stable isotope data to see if actually there is a process of contribution to infiltration there and recharge. This of course needs to be linked with roof collection systems like are linked with more for domestic use purposes, but the idea is again to harvest water that is available and otherwise lost, and to continue improving. And sometimes the woman can do some horticultural activities, gardening, and things like that from this roof collection. Also for fish and farming, in this case you see that the structures are isolated with some plastic or geomembrane. The idea is in this case to improve or to make it as the main goal the production of these additional sources of livelihood. You know. And we learn, of course, that for instance in these systems, of course, when there is naturally built, we need to cover and protect from livestock coming into the reservoir, of course, because of the risk of contamination and things like that. And of course, if we found the way to build some parts of concrete or stones, then we can also improve or increase the life of these reservoirs. For example, around 20 years that can be last. And these are images from actual project. This is Cosecha de Agua, again in Nicaragua, but now with the Switzerland Corporation, they are quite interested in building, actually doing things in the field. And we have been working with different structures, in this case, roof collection, connected with a geomembrane, rotoplast, which is more common and is available in the market, semi-board cisterns, and this is a kind of specific tank that was invented by a university in Honduras. Actually, it's called Zamorano. Probably you hear about that. It's actually get a lot of support from USA, I would say. So this is a type of specific tank that they have been working with and spread along the region. All the capacities, we also have exercises on cost. Some of them are more costly than others. The project has been working a lot on this spreading of the technology in Nicaragua in the dry corridor. Again, of course, you will have more expensive systems if you have to waterproof, to add these structures like the geomembrane, the plastic incorporation, as compared with naturally waterproof systems. For example, where you can find structures in the land that can be used more or less close to the way it is. For example, with soils with a lot of clay content, then you don't need to isolate. So there is several kind of examples, and testing that they have been doing in the project. Different costs also. Of course, the process, it is, if you are going to build something mechanized, of course there is an intervention, cleaning, excavation, in the process of building. You will have the pipes, for example, when you have to connect with the irrigation systems in the houses. So all this process has been supported by this project. Actually, this cosecha de agua was has a first stage, and now we are in the second one, again with the Consulta cooperation. And of course, there is also some part of water technologies to harvest or contain actually the water in springs. And this is different objectives that might have, for example, water, drinking water purposes can be part of the process of also productive objectives. So the types of micro dam, concrete, they have been using some structures of collection and production, also in high sites, and practicing different alternatives on this idea, not just harvesting from the rain, but also from the springs that we can find. And from soil and water conservation, as you see, the same thing, but in Nicaragua here, dams with bioengineering practices here, filtration trains, in order to have the water collected there and promote the slow infiltration in the system. And similar things, this is also part of what has been done in Honduras, living barriers, in order to hold back erosion and slow the sediment. So it's part of the processes of promoting soil and water conservation. This is also infiltration trenches, but individually built in fields like this is a combination of let's see, citrus, fruit production, and also some barriers, some alternative cultures there in the system. From these examples of what to do in the field, we have been also working in a research line, which has to do with this famous model that you may have heard. Is the soil and water assessment tool, actually promoted and first started in the USA from the university. I don't recall the name. It started in the 80s, but even if it started really far away in time, it is constantly evolving and updated. So we continue working on that and developing a research lab. We have been doing a lot of theses, master thesis here in Calgary, with this model. And the model actually uses climate data as an input. We need a digital elevation model of the watershed. We need soil types, and we need land cover and land use. Those are the main inputs that we need to get in order to use and run the model. The model tries to build with you on a baseline. Part of the indicators that we can use in the baseline or cycle that I mentioned before. The digital elevation model, water network, we have to define it into the watershed, the limitation of two basins. You need to add information, vegetation, soil type, slope, and from there you create the hydrological response units that the model asks for. Then you add the climate part of rainfall temperature, go through a simulation to get the slope, the flow, and the sweat tube is that kind of extension of the model, also helping to get the different compartments of the water cycle, like runoff, like percolation, and other variables that I will show later. Calibrated model, of course, this is always a drawback, limitation. Sometimes you don't have flow measurements in the field for a long-term period, and calibration usually is more complicated in our region, but probably in the United States you usually have this information available in some places, so it makes it, let's say, more feasible to use a good calibration. And at the end, what you have is water production and erosion. Water yield from the watershed and erosion produced in the watershed. So results can be reported, for example, in a map where you have the different sizes or ranges of erosion in the area. You have, for example, the lightest color there is showing lower erosion rates, less than 10 tons per hectare, up to the chart the water, the base flow it is, how much goes to the lateral runoff, and how much goes to the final water via the production as a whole. So you can have a lot of different sort of results and analysis using this model that has been our research line. For example, that one has to do with the modeling, what is going to happen with the different products of the model, like percolation, runoff, water yield, and sediment production with the different climate change scenarios. You can also model that and see what is going to happen from one condition to another. This is a thesis that has been done before the new names of the climate change scenarios. Now they are the different setup, but at the same time, this gives you an idea of what is going to happen and what the model can be done with this, bringing a new layer of conditions in terms of water. And also the model gives us this sort of summarizing schematics of the different compartments of the water cycle, similar to what I've shown in the graph before, saying, well, how much is going to return flow, how much is runoff, how much is the average curve number, I mean, sort of the different concepts that are included in the model. Actually, SWOT is a model that uses the universal equation of soil loss. You may hear about that also. And this is actually the core of many of the models that have been using now with the purpose of water balance modeling in the waters. So this is kind of still relevant and currently useful. And the second line of research that I wanted to show you that has to do with the soil water conservation is came from a model from a project that we just finished in 2018 in called Water Malak. We work in coastal watersheds in different countries in our region. In Haiti is one the case that I want to show. We work in Mar del Plata, Argentina. We work in El Salvador and in Mexico. So the idea is to use an additional model quite related also to SWOT, coming from an analysis of the main problems of the watershed of the region that we have been working in Haiti, for example. Again, a country with extreme poverty, problems with access of basic services, as you have seen there. You may hear about the Haiti situation in terms of the lowest level of development index, lowest level in terms of, let's say, fourth in the world in levels of development actually. And of course the household income really low. So actually this country has in this area a lot of problems like loss of mangroves. This is the approach of Miguel, for example. Loss of mangroves is a problem, deforestation, lack of drinking water, flooding problems. And from there we started with an analysis of erosion also. In this case we use the plain USLE, which is the revised universal equation loss, which is, as I mentioned, part of the core of SWOT 2. But in this case we use the plain equation and found that, again, for the lack of detailed information needed for other more sophisticated modeling. So we use some part of remote sensing data to complete especially the weather data, rainfall and temperature. So we can identify different parts of the landscape with the levels of erosion, extreme, medium, and low erosion rates, and from there understand what or where to put the different activities and options. And that is what our second model gives us. You may have heard about this RIOS model. This is a resource investment optimization system which was developed by the Natural Capital Project by Stanford University. This model has to actually put in place the different practices based or studied from a budget that you may have, or at least propose ideally one budget to start putting in place the different practices. And of course we need to, this is very much used also when you are going to design, or for the water funds designs that you have here. Maybe in Latin America there are a lot of water funds that actually is a private public arrangement in order to do watershed management. So the idea is to see the land use changes. We want to promote a transition from what we have now in the watershed. We want to move to a more sustainable part of, through a more sustainable land use. We need to see which are these factors, what are the determinant elements, what are the things that we need to intervene in order to produce these transitions or these changes. And again, we need to know the activities to promote this transition or this change. Of course, there is a kind of important part of the model that has to do with the priority area selection and gives you with the budget. You need to include at least a budget, the cost of each different practice that you are going to promote. And of course, where to put. At the end of it, we give you an investment portfolio, spatially distributed in the watershed, trying to optimally produce ecosystem services or water ecosystem services and also at the lowest cost possible. That's the idea. Again, it gives you a portfolio land cover, how the land cover will change with the different activities you are going to promote. Compared with the baseline, the difference between them will give you actually would be possible with a budget that you will put in place that can come from different projects or resources coming from different stakeholders. But in terms of practicing or academic purposes, we usually put up a budget that is more or less feasible in the area we are working with. And of course, when you have more money available to spend, you will have more impact in erosion reduction. In this case, in percentages. So what we did in IEP was to see actually which practices have been there in place in the past, because usually it's not that much of a recommendation to go through this model and try to implement a quite new practice that has been not tested before. So we use this, for example, you will see there forestation, you see clearing of canals for ecological restoration, more or less these activities regarding forest restoration with living barriers. The figure is not that nice to see there, but some few activities that are actually in place there. We also produced this, unfortunately in Spanish, but we have documented the process there in that manual. So the idea is to propose some budget in the model. In this case, we use a floating budget of $350,000 for, that's the code for the RAS amount resulting from this transition. We want to move through a transition to restoration, agriculture, and protection for an 8-year period in a model, 8-year horizon. So the idea is to see how much of these areas are going to change with the different type of uses that are going to transform in the landscape, how many hectares and percentages that are going to change thanks to this budget that we need to allocate properly and wisely. This is another example in Mexico. Here you can see more specifically the different practices here, not the transition as a result that I mentioned, I showed before. But for example, you see there in the violet ones, you see this is dead barriers. Particularly, where are they going to be placed in the whole watershed? So the idea is again to see the activities we have to promote, where and how are we going to be expended that budget, and how will be this allocated at the different practices that we are going to promote. Of course, this has an important component when there is actually advisable, to have this decision-making part in the model, bringing experts with you, bringing experts that know the area and wants to actually advise to the researchers, for example, to say, okay, actually we know that the protein banded crops are the ones more adopted. We actually know from experience that it is actually a good idea to invest, to put more money of that budget in this sort of practice. Then you can also decide on these aspects with expert aid. And well, at the end, I wanted just to show you additional information globally available that you may hear also. There is a sort of world overview of conservation approaches and technologies with World Cup. There is a convention, a combatant certification of the United Nations, and they have been working working a lot to collect the practices, to collect experiences, what I mentioned in my cycle as systematization of information, which is really useful to start any process. For example, the approach there is to work through sustainable landscape management. Okay? So the idea from there is, if you have a landscape where you can still prevent or avoid degradation, avoid erosion, then you should work on that with some specific practice. If you have signs in your landscape with erosion already, of course the approach will be reducing it, and there are these parts that I mentioned before, it's quite difficult to recover from there, but restoration or try to go through reversion of the situation. And as I mentioned before already, there have been classified also the different measures to be used, like the agronomic measures. This is something that is used a lot in the United States because of the sort of flat landscape that you have. You can do this rotation, this sort of collecting the rotational part, to put some organic matter into the second cells, try to do this no-tillage process. So this is something quite also used in my country, Paraguay, which is also flat, and we do a lot of maize, soybean, similar to the process of what we can do there. And there are other places where you can put vegetative measures like perennial grasses with long last, and are, again, depending on the specific condition of the area that you are going to intervene. Structural measures, sometimes there is no way to cultivate if you don't cultivate, you don't organize the food in a good way, the profile of the soil, and then you have a permanent erosion. And the last one, they manage also a fourth level of measure, that is management measures, meaning that you don't actually put things in place, you don't put works in place, but you change the way of producing things. For example, there you can think about managing in a watershed a livestock farm, where you move from a completely traditional way of producing the coal to introducing trees in the landscape, for example. So you don't actually put on structure specifically, but you move through a new or better way of producing the specific activity that they already have in place. So from the sort of research that they have been doing, the world class people mentioned the systematization of information, where they say that this is from the database that they will find in the platform they have in the internet. So they said that countries are already implementing these practices, but there is need for more in order to promote it better. For example, evidence of impact and value recognizes the importance and also expands the benefits. And what they have been showing in this figure is, for example, that for prevention, the first stage, what is more used are the agronomic measures, the brown one, bar, to reduce also the second one, the combination of agronomic and structural measures, and to reverse also structuralist more use. So this comes from analysis that has been done. There is a recent paper from 2019 coming also from this report on what has been done in the time, and trying to give you an overview of the whole world in terms of sustainable landscape management. And you will see also in this platform global resources available, like the sustainable management technologies, the approach. There is also part of carbon-based projects, land degradation, conservation. Of course, there is not everything there. Sometimes you will say that, oh, the map is not available yet, but the process of collecting information and sharing in an organized way these resources are quite interesting. That quite advisable, and there is also statistics of people contributing and using the resource. So that's something that more or less what I wanted to share with you. Of course, you may have some questions and comments, and you're most welcome. I am not that organized as Miguel with the web page that they have many things there, but we are building it. You have my email, and of course, welcome to help on any questions and information and engaging together. Yes?
Do you have any specific examples of practices from water smart cities? You mentioned that really early on.
Yes. So from water smart what we have been working with is, of course, the green part of the city, which is promoting, as I mentioned, the biological corridors at the urban areas. There is not just putting trees into the riverside, but here in Costa Rica it's quite interesting that there is a lot of effort in organizing a committee of biological corridor. People from different institutions working in that catchment. For example, you have the municipality of San Jose, you have there is a company for electricity production also located in one of the waters that are have part of the intervention in the city. So a lot of work together in order to promote this, and a lot of work in order to see where to put, how to deal with people in the areas. There is also in Costa Rica a national strategy for clean rivers, and that is focused in cities. So part of the strategies there is measures regarding recycling, plastics, and of course cleaning the river, that are like measures quite of reactive. But you can also see some parts of the watershed in this. There are actually two priority watersheds that are starting with this strategy. They are doing like, rain gardens. The gardens that are put in place in order to collect the water and recovering actually some open areas or abandoned areas in the city, and to build from there some catchment, small ones, and planting some species like collecting and renewing, also like bio gardening are part of the experience that has been done here, and a lot of let's say manuals and reports that are also in place that if you are interested I can look it for you and share, because we have some reports on that that we have been working with these people too, but these specific parts are some expertise in other areas that have been producing material and reports on that. More or less this I can say. There are many other things, but we are now in the process of collaborating with Turrialba municipality. The idea is to build on a green roof in the municipality as a pilot, together with solar panels into the roof, you know. So the idea is to go into this smart city example, starting from the municipality here, which is a very good partner of our work here in Cali. But yeah, mostly is the biological corridor, some parts of biogardening, and the social part of this effort that needs to be done, I would say. Yes.
When dealing with the public, what are some obstacles that y'all face from getting from the current state to that prospective model that you showed us?
Well, the main thing is, you know, one of the reasons that the project, when I started here, was focusing not just in the practices, in doing activities in the area, in measuring stuff, because that we know. But the problem was how to do it, how to deal with people. So that's why we with our set of researchers, go and move through the concept of co-management. That's the main issue, trying to get all interested parties sitting together and sharing their resources. You know that difficult it is to put a minister, like having a agency in an area, in a rural watershed, let's say, with the different ministers that has to do their mandate there, to put them together and just share their operative plan as an institution, to put together and try to see the translates, the common part. This is quite complicated. So to work towards this co-management was the main issue. And the way to solve, at least in the experience that we had in Honduras, I can recall it very well, it was like, okay, in a watershed you will have different municipalities working or sharing the landscape. They all want to have the lead in activities, but the way to go is to work through a shared process. They all going to have one piece of their land included in the projects, included in the priority, not just one or two. We have to give some equity in the process. That was one understanding and one lesson learned from Honduras. We put all the municipalities together to share the processes in our project. And then the other one for the water harvesting project that I showed, this is another problem because you want to put all as much as possible of this water harvesting work, this infiltration works, but sometimes there is the problem of political interest, and you go through the areas, through the municipalities, and they say, well, my areas are this one. These are my clients. Please go ahead and put and help them. But the way to move or to actually overcome with this problem was like the technical aspect of criteria to prioritize technically which areas are the most suitable to build the different works. So the technical aspect could help there. And if people want to force you to do what they want, then you have no. This is the criteria, and from there you can convince them. So that's part of some of the challenges, and that's the more complicated things actually in watershed management. Not just the parts of the works, the practices that we may already know, but how to make it work with people. That's the main thing. Yes.
Anything else, Mr. President?